This is Module 4, Lesson 21. We're going to find solutions to a system of linear equations using graphing. There's lots of ways to find solutions to a system of linear equations. We're starting out with graphing. Now we're going to write linear equations from graphs. You've done this before. This is a review. Then we're going to identify the solution for a system of linear equations from the graph. It's the point where the two lines intersect. Now, let's start out by solving a few of these. Notice they give us a system of linear equations. They ask us to solve it by graphing. That means we graph these and then we find out where the two lines intersect. We know when we're graphing something that we use the equation y is equal to mx plus b. This is called the point-slope form. Here's your point on the y-axis, your y-intercept, your m is your slope, tells you where to move. B is where we begin, m is where we move. So when I'm looking at the equation y is equal to 4x plus 1, I begin my plotting at 1 on the y-axis. Go up on the y-axis to 1. My slope is 4. See, m is 4. Your m is change in y over change in x, or rise over run. When it's 4, that means 4 over 1, because 4 divided by 1 is 4. Okay, so up 4, 1, 2, let's see, 1, 2, 3, 4 over 1. Up 4, 1, 2, 3, 4, and over 1. And now we've got a line that we can draw. Okay. All right, now let's draw the other one. Let's do the other one. Y is equal to negative 2x minus 5. Here's our b, it's negative 5. So we go down to negative 5. 1, 2, 3, 4, 5. It's right here. Okay, and my slope is negative 2. That means I go down 2 and over 1. Down 2, over 1. Down 2, over 1. Okay, and now I draw my line through those points to create my line, and I see where all of this intersects. Okay, let's see, up 2 and over 1. Let me get this straight real quick. Oops. All right. Now let's see about where these two intersect. And they intersect right about here. What are the coordinates for that? That would be negative 1, negative 3. Okay? Negative 1, negative 3. The solution's at negative 1, negative 3. Okay? Let's look at the second one here. Oh, no, I'm sorry. We're not doing the second one. We're doing the third one. Let's go down to the third one. If I'm plotting this one, y is equal to x plus 5. My b starts at 5. Okay, so we go to 5. 1, 2, 3, 4, 5. My slope isn't shown, so we know it is 1. That would be up 1 and over 1. I'll find my pen on here. Okay. Up 1 over 1, so that's a point there. Up 1 over 1, that's a point right there. Okay, and so I can put in my line. All right, now let's try this other one. This starts at negative 7, so we need to come down here to negative 7. Let's see if I can find this on here. So let's go down to negative 7. 1, 2, 3, 4, 5, 6. Let's see, that would be 7 would be right there. Okay. And then my slope is -3. So I go down 3, 1, 2, 3, and over 1. Okay, so now all I've got to do is plot my line. And we've got to extend this line here and see where the two of them intersect. And if you extend this line down, and when you extend the line down, what you wind up with is the point right here. Let's see where that point is. That point is actually located at, let's see, negative 1, 2, 3, 4, 5, 6, 7, -2, okay? -7, -2. So your solution there would be -7, -2. Okay? Well, let's go to the next page. If we're plotting these, let's look at number 5. Let's see if we can plot number 5. If we're plotting this one, we would start at 2. And then our slope is 1/3. We go up 1 and over 3. Up 1 and over 3. Up 1 and over 3. Okay, and then we can put our line through it. Then we've got x is equal to 9. Okay, let's see what we can do there. X, we go to the x-axis. Okay, we know we're drawing a line through it at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we want a line that goes through this at 9. Talking about this line right here. Where do the two of them intersect? Right here at this point. Okay, so let's figure out what point we're at. That point is at 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. 9, 5. Okay. Now let's look at number 6. If we're plotting this one, y is equal to mx plus b. So our solution was at 9, 5, right? For this one, on this one, we start at -5. 1, 2, 3, 4, 5. Okay, our slope is 2, so that's rise 2 and run 1. Up 2 over 1, up 2 over 1, up 2 over 1. See, up 2 over 1. You can keep going as long as you want to, or you can just draw your line through it. All right, now let's look at this other one. Y is equal to 2x, and there's nothing there for the b. That means it's 0, isn't it? So you start at 0, and your slope's 2. Up 2 over 1. Up 2 over 1. Up 2 over 1. Okay, so let's put our line through here. We've got two lines that are parallel. These will never intersect. If the two lines will never intersect, then there is no solution. It's not that the solution is 0. There is no solution. There's no point at which the two lines will intersect. Okay? Now, let's look at number 7 together. Number 7 is a little different. I can plot this first one pretty easily. It's in the form y is equal to mx plus b, right? 2 is our b, so we start there. Our slope is -2, so we go down 2 and over 1, down 2 and over 1, down 2 and over 1, down 2 over 1, okay, down 2 over 1, down 2 over 1, and we can draw our line. All right. But this one, 5x minus 2y equals 14, is not in the format of y is equal to mx plus b. I need to get it into that format. I need just the y over here. So what if I subtract the 5x from both sides? Your 5x is gone. We've got now is -2y is equal to -5x plus 14, okay? I'm trying to get this to say y is equal to, so let's divide both sides over here by -2. I've now got y is equal to -5 divided by -2x, and then I got 14 divided by -2, which is -7. Negative divided by negative is a positive, so I got 5/2 x minus 7. See, now I've got it in a form where I can plot it. Let's start at -7. 1, 2, 3, 4, 5, 6, 7. And now I'm going up 5 and over 2. Up 1, 2, 3, 4, 5, and over 2. Look, the line's going to go right through that point, isn't it? I found the point of intersection. It's right there. All I've got to do is read it off the graph. So my solution is at 2, -2. Okay. See, that's the solution. That's the location where the two lines intersect. It's on this line and both this line at the same time. Okay, now we're going to skip 8. All right. And we're going to skip 9 because we're not going to keep doing lines where we have to solve for y. I don't think you'll have to do too many of those. Okay. I do want to show you number 10, though. Let's look at number 10. Let's plot this one. Y is equal to x plus 6. So we start at 6. 1, 2, 3. Let's see. 1, 2, 3, 4, 5, 6. Okay, let's start at 6. And then our slope is 1. We go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. Okay? And we can put our line through it. Now, here's our other one. We need to plot this one. What I've got is 2x minus 2y equals -12. I need this to say y is equal to mx plus b. So I need to solve for y. Why don't I subtract the 2x from both sides? And I have got -2y is equal to -2x minus 12. Okay. Now I need it to still say just y on both sides. Let's divide both sides by -2. That gives us y is equal to -2 divided by -2 is just 1. So it's 1x. -12 divided by -2 is 6. Okay. Y is equal to x plus 6. So we start at 6. 1, 2, 3, 4, 5, 6. And then our slope is 1 up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay? Let's plot. Oh, I'm in the wrong one. Y is equal to x plus 6 is right here. hold on. This replaces this because that's what it was. Y is equal to x plus 6. Notice it's the exact same equation on the top and replacing this one. So if I'm plotting this one, y is equal to x plus 6, I start at 6, and my slope is 1, up 1 over 1, up 1 over 1, up 1 over 1. See how the points are right on top of each other? And if I were to plot this line, they're going to be right on top of each other. The two lines will be exactly on top of each other. Okay? See? I have two lines that are right on top of each other, the exact same line. You can tell from the equation it's the exact same line. Now, what do I know about the solutions then if these two are the exact same line? What do I know about every point on here? Every point on here is on both lines, isn't it? The solution is that there are an infinite number of solutions. Every point on this line is going to be on both lines. Okay? Now, these two ask us to find the solution and write the system of equations. So first off, we know the solution is where the two lines intersect. That's pretty simple. This is at -1, 2, 3, 4, positive 1. -4, 1. Let's find the equation for this line because we're finding the system of equations. We've got two lines, two equations. We know an equation starts with y is equal to mx plus b. Let's figure out where b is. B is right here. Okay, so this is at 1, 2, 3, 4, 5. All right, now your m is your rise over your run. Up 1 over 1, okay? Y is equal to 1x plus b. And 1x is just simply x, okay? So there's the equation for that one. Now let's find the equation for the other line. Let's find the equation for this blue line right here. Y is equal to mx plus b. Where's the b? The b is down here. It's at -1, 2, 3, 4, 5. It's at -5. Okay, now we need to find our slope. Let's find 2 points where the grid lines meet, where the points on the grid line. This is down 1, 2, 3, and over 2. Y is equal to -3/2 x minus 5, okay? There are our two equations, okay? This is our system of equations, the red equation and the blue equation, and the solution is where the two of them intersect. Okay, on to, what would be our solution here? It's right here, isn't it? Where the two lines intersect. That would be at 1, 2, 3, 4, 5, 6, -1, 2, 3. The solution is at 6, -3. Okay, let's find the two equations. Let's try this equation first. Y is equal to mx plus b. Okay, our b for this one would be at, where's the b on that? That's 0, isn't it? Okay, so let's find the m. Let's find 2 points on the line. It's down 1 and over 2. Your slope is -1 over 2x plus 0, so I don't even have to put plus 0, do I? Let's do the other equation. Y is equal to mx plus b. Let's do this red one here. Okay, our b would be at 1, 2, 3, 4, 5. So that's plus 5. Our m, our slope, we find 2 points that are on grid lines. Okay, here's one, there's one. This is down 1, 2, 3, 4, and over 1, 2, 3. Down 4, over 3. You got to have your x there. Y is equal to negative 4/3 x plus 5. This is your system of equations. All I did was write the linear equation for each line. And this is your solution. It's where the two lines intersect. Okay, let's look at number 4. Let's try it. It says solve each system by graphing. We're going to graph them and figure out where they intersect. Okay, we know this is y is equal to mx plus b. B is our 3. 1, 2, 3. Okay. Our slope is 2/3. Up 2 over 3. Up 2 over 3. Okay. There's that equation. Okay. And then this one. We start at -7 on the y-axis. -1, 2, 3, 4, 5, 6, 7. Okay, and then we're going down 1 and over 1. Okay. And I can draw my line. And the line's going to go right through that point right there. Okay, so what's my point? Let's count it. This is at -1, 2, 3, 4, 5, 6, -1. -6, -1. Okay. Let's see. Okay. Let's try number 6. Y is equal to -2x plus 7. Let's start at 7. 1, 2, 3, 4, 5, 6, 7. My slope is -2. That's down 2 and over 1. 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 Down 2 over 1. Down 2 over 1. You can do that as long as you want to, guys. I just did it for a good way, so it's easy for me to draw my line and make sure I got them through the points. And then this is y is equal to 5. So what I do is I go to the y-axis. Okay, and the line's going to go through the y-axis at 5. 1, 2, 3, 4, 5. You're talking about this line right here. Okay? And if that's the case, this is where they intersect. Let's figure out what that point is. That's at 1, 1, 2, 3, 4, 5. 1, 5. Its solution is 1, 5. The solution for this system of equations is 1, 5. How about this system of equations? Again, y is equal to mx plus b. We'd start at 2. Okay. This is up 1 and over 2. Up 1 and over 2. Up 1 over 2. Up 1 over 2. Okay. I'm going to draw my line. All right. On this one, we start at -3. -1, 2, 3. Okay. Down 3 and over 4. Down 1, 2, 3 and over 1, 2, 3, 4. Down 3. 1, 2, 3 and over 1, 2, 3, 4. Okay. And there would be our intercept. This is at 1, 2, 3, 4, 0. This is at 4, 0. Okay, that is your solution to that one. Now we're not going to do 10 because you'd have to solve for something, and we're not going to do 12. So we're going to leave from those as they are. And I want to run into the workbook real quick. This page 13 has a good summary of what's going on here. When you have a system of linear equations, and see, these don't say y is equal to mx plus b, but they got your x and your y in there, right? You could solve them for y is equal to mx plus b if you wanted to, right? They have plotted them. They've solved them. They've plotted them. They're right here. This is the solution for them at 4, -1. It's the only point that is actually on both of these lines at the same time. This is the only point on both lines. Only one is a solution for both of them. How can we prove that it's a solution for each one of those equations? How can you prove 4, -1 is a solution? You can substitute these x and y in, can't you? If I have the equation x plus y is equal to 3, see, that's this line. If I plug in my 4 for my x and my -1 for my y, 4 plus -1 is 3. If you solve that, 4 minus 1 is 3 is equal to 3, okay? So that proves that this is a solution. 4, -1 is a solution for this line. Now let's try the other line. X minus y is equal to 5. Let's plug these in. The x is 4, the y is -1. 4 minus -1 is at 5. Is 4 plus 1 equal 5? It certainly is, so that means this one is actually a solution for the other equation. This proves that 4, -1 is a solution for each one of these equations. And where the two of the lines intersect, that is the solution for this system of equations. Okay, it's the only point that's a solution for the system because it's the only one that's on both of them. If you look in your workbook on page 308, 309, it gives you this one. They ask you to do it. If I were going to plot this, I can plot the bottom one pretty easily because I know to plot it's y is equal to mx plus b. And here my b is 3 and my slope is 4. Up 4, 1, 2, 3, 4, and over 1. Okay? And I can plot that, can't I? All right. Now let's try this one. Y is equal to, now let's try this one. X plus y equals -2. Okay? X plus y is equal to -2. Let's solve for y so we can plot it. To do that, I would subtract x from each side. This becomes y is equal to -x minus 2. See, now it's in y is equal to mx plus b form. All I've done is rearrange it. I start at -2. My slope, since there's nothing there, you know it's 1, so that would be down 1 and over 1. Okay, so let's draw that line. And when I do, the place that the two lines intersect is right here at -1, -1. The ordered pair where the graphs of the two lines intersect is -1, -1. That's the solution for those two. Verify that the ordered pair named is a solution to x plus y is equal to -2. See, that's their first equation they got up there, right? Let's plug it in. Here's my x, here's my y. Is -1 plus -1 equal -2? Yes, it does. So it is a solution. We have verified that. Now verify that the ordered pair is a solution for the other equation. So we're proving that it's on both of these. Let's see. Y is -1. It's -1 equal to 4 times -1 plus 3. Is -1 equal to -4 plus 3? Is -1 equal to -1? Yes, it is. Okay. Could the point -4, 2 be a solution for the system of equations? Let's look and see. -4, 2 would be right there. Well, let's look at that. If I extended this line out, it's going to go through that point, isn't it? But this point is not on this line, so it's not a solution for the system. It is a solution for this one equation, but not for the system of equations. Okay? All right, I think that covers everything that we really wanted to do on this. So what we have proven is this, guys. If you've got a system of equations, you can rearrange them, put them in the form y is equal to mx plus b if you need to, plot the two lines, and you can find the solution for the system is the point where the two lines intersect. All you have to do is read it off the graph. Okay?